Let's see what it takes to write a program like this. So you're going to get an interval and then you're going to display each and every individual number from that interval and say whether it's odd or even. And here's the program. First, we're taking the lower number and then we get the higher number as input from the user. And what we're going to do is write a for loop, and the range would be the lower number till the higher number because it's exclusive. So we're going to add that +1 so that even number 2 is included in the range. Now, once we enter the for loop scope, we want to determine if this number is even. For an even number, the remainder when we divide by 2 would be 0. So number %2 gives you the remainder. If it is 0, we would print number is even, else we would print number is odd. As we go further into the course, you'll see plenty of programs which use decision structures within loops. Alright, here is the next example. We're going to write a program that displays 10 by 10 multiplication table this way. If you observe closely, the elements in the first row are multiples of 1, the elements in the second row are multiples of 2, and so on and so forth. Here is a preliminary program that I've come up with. I've written for number 1 in range 1 to 11. So when Python interpreter reaches this code and executes it, the value inside number 1 variable will be 1. As we go to the next line, we have for number 2 in range 1 to 11. So number 2 will be 1 as well. So I'll be printing 1 multiplied by 1, which is 1. In the next iteration of inner for loop, number 2 will be 2. So 2 will be printed. In the next iteration of the inner loop, number 2 will be 3. So 3 will be printed, and you'll get all the multiples of 1 after you finish executing the inner for loop. Great. So now we got the first row elements. Now let's see how we get the second row elements. So once the inner for loop is executed, the program flow goes back to the topmost for loop. So number 1 will be 2 now. Okay, so it enters the inner for loop. So number 2 starts with 1. So 2 multiplied by 1 is 2. And then you'll have 4, 6, 8, and so on and so forth. So this repeats for every number from 1 through 10. I'm confident that this program displays all the numbers I want, but does it display it as a 10 by 10 table? Let's find out by running it. Oh no, looks like it's printing everything line by line. While we have all the multiples from number 1 till 10, they're not being displayed in a 10 by 10 table. So let's try to modify this program to make sure that the multiples of 1 are printed in a single row, and then we go to a new row and then print multiples of 2, and then so on and so forth. Let us re-examine the desired output. It looks like all the numbers are spaced uniformly with a fixed space allocated to each number. We already learned how to do this when we discussed formatting options in chapter 2. Also, the print statement should not go to the next line after printing each number. So we will have to set the end argument in print function to empty string. Once we finish executing inner loop, we have to go to the next line. That is when we have to display a new line character using print function. Okay, so with this knowledge, let's try to rewrite the code, and this is what I've written. I've formatted the product of number 1 and number 2 in such a way that I allocated 5 spaces, and because it's an integer, I'm using the format specifier D. If it were a floating point number, I would have used f. Okay, so 5d is going to assign the integer 5 spaces. All right. And then within the same print statement, I'm writing end is equal to empty string. So that way I'm not going to a new line after printing the number. So once we print a whole row of numbers, we come out of the inner for loop. That's when I'm printing the new line character. And we're going to go to a new row, and this would repeat till multiples of 2 through 10 are printed. Okay, here is the final example I have, which is displaying data in a table. For an object of mass 2.25 kilograms, you'll have to draw a table with accelerations from 1 through 10 meters per second square and the corresponding force that is needed to achieve those accelerations. From Newton's second law, we have force equals to mass into acceleration. So here is the table that we're trying to display. I'm going to directly discuss the program that prints this table. Okay, so I have mass, which is constant in all of our calculations. So I have the named constant as mass with the value 2.25. So for acceleration in range 1 through 11, so that way I get 1 through 10. So I'm going to compute the force and print it with these format specifiers. So when I say format acceleration, 6d, I'm assigning 6 spaces in which the acceleration values are going to be populated. After which I've said format force 18.2f. So what this means is I'm assigning 18 spaces. In those 18 spaces, I'm going to populate the force values up to 2 decimal precision. Okay, so you'll get better at this by practicing more examples. I hope these 3 examples gave you a good overview of what can be written using loops.